Black holes are one of the most fascinating objects in the universe. These mysterious objects are formed when a massive star runs out of fuel and collapses under its own weight. The gravitational pull of a black hole is so strong that nothing, not even light, can escape from it. This property makes black holes one of the most intriguing objects in the universe. The first concept to understand about black holes is the event horizon. The event horizon is the point of no return for anything that approaches a black hole. Once an object passes the event horizon, it is impossible for it to escape the gravitational pull of the black hole. The event horizon is the boundary around the black hole where the gravitational pull is strong enough to prevent anything from escaping. The size of a black hole is determined by its mass. A black hole with a mass equal to the Sun would have a radius of approximately 3.7 miles, 6 kilometers. A black hole with a mass of 1,000,000 suns would have a radius of approximately 1,800 miles, 3,000 kilometers. The largest known black hole has a mass of 40 billion suns and is located in the galaxy NGC 1277. One of the most interesting properties of black holes is time dilation. Time dilation is a phenomenon where time appears to slow down in the presence of a strong gravitational field. Near a black hole, time dilation is extreme. If you were to approach a black hole and look back at Earth, you would see time passing more slowly on Earth than it does for you. This means that time passes more quickly for you than it does for someone on Earth. Another property of black holes is that they emit radiation, known as Hawking radiation. This radiation is created by pairs of particles that are created near the event horizon of the black hole. One of the particles falls into the black hole, while the other escapes as radiation. This process causes the black hole to lose mass over time. The study of black holes has led to many important discoveries in physics. Black holes are a testing ground for some of the most fundamental laws of physics, including the laws of thermodynamics and the theory of relativity. They have also helped scientists better understand the structure and evolution of the universe. Black holes are also important for astronomy. Astronomers use black holes to study the behavior of stars and galaxies. The gravitational pull of a black hole can cause nearby stars to orbit around it, creating a binary system. By studying the behavior of these binary systems, astronomers can learn more about the properties of black holes. Black holes are also important for the study of dark matter. Dark matter is a mysterious substance that makes up approximately 27% of the universe. Scientists believe that black holes may be one of the sources of dark matter. In conclusion, black holes are one of the most fascinating objects in the universe. They are formed when massive stars collapse under their own weight, creating a region of space where the gravitational pull is so strong that nothing can escape. The study of black holes has led to many important discoveries in physics and astronomy, and they continue to be a topic of great interest to scientists and the general public alike. White holes are one of the most fascinating and intriguing concepts in the field of theoretical physics. They are the opposite of black holes, in the sense that they are regions of space from which nothing can enter, but from which matter and energy can be emitted. The concept of white holes was first proposed in the 1960s, by the physicist Robert Dicke. White holes are theoretical objects that are the opposite of black holes, in the sense that they emit matter and energy instead of absorbing them. Whereas black holes are formed when massive stars collapse in on themselves, white holes are thought to be the product of hypothetical processes, such as the Big Bang or the collision of two black holes. In theory, a white hole would have a region of space around it that matter and energy cannot enter, but from which matter and energy are emitted. This region is called the event horizon of the white hole. The event horizon of a white hole would be similar to the event horizon of a black hole, but with the opposite properties. Instead of matter and energy being pulled into the white hole, they would be ejected from it. The concept of white holes is still largely theoretical, and there is no direct evidence for their existence. However, some astrophysicists have suggested that certain astrophysical phenomena, such as gamma-ray bursts, could be caused by the emission of matter and energy from white holes. One of the most interesting things about white holes is that they violate the second law of thermodynamics. This law states that the entropy, or disorder, of a closed system always increases over time. However, if matter and energy are continually emitted from a white hole, the entropy of the system would decrease over time. This is known as the white hole entropy problem. Despite the theoretical nature of white holes, they are an important concept in the study of black holes and the structure of the universe. The idea of white holes has led to important developments in the field of quantum gravity, and has helped scientists better understand the nature of spacetime. White holes are also an intriguing concept in science fiction, often portrayed as a gateway to other dimensions or universes. While there is no direct evidence for the existence of white holes, they remain a fascinating and thought-provoking concept in the field of theoretical physics. In conclusion, white holes are a fascinating and intriguing concept in the field of theoretical physics. They are the opposite of black holes, emitting matter and energy instead of absorbing them. While there is no direct evidence for their existence, they remain an important concept in the study of black holes and the structure of the universe. White holes are a fascinating example of the power of theoretical physics to push the boundaries of our understanding of the universe. Wormholes are a fascinating concept in the field of theoretical physics. They are a type of hypothetical tunnel or shortcut through spacetime that could potentially allow for faster-than-light travel and travel through time. While wormholes are still a largely theoretical concept, they have captured the imagination of scientists and science fiction writers alike. The concept of wormholes was first proposed in the 1910s by the German physicist Ludwig Flamm, who suggested the possibility of a white hole at the other end of a black hole. However, it wasn't until the 1930s that the idea of a wormhole as a shortcut through spacetime was first proposed by the mathematician John Wheeler. In theory, a wormhole would be a tunnel or shortcut through spacetime that connects two distant points in the universe. A wormhole would be formed by the curvature of spacetime, which can be warped by massive objects such as stars and black holes. If the curvature of spacetime were warped in just the right way, it could create a tunnel that connects two distant points in spacetime. One of the most fascinating things about wormholes is the potential for faster-than-light travel. Because a wormhole could potentially connect two distant points in spacetime, it could allow for travel that is faster than the speed of light. This would be possible because, while nothing can travel faster than the speed of light within spacetime, a shortcut through spacetime could allow for travel that appears to be faster than light from the perspective of an outside observer. Another fascinating aspect of wormholes is the potential for time travel. Because a wormhole connects two different points in spacetime, it could potentially allow for travel through time. This would be possible because a traveler could enter one end of the wormhole and emerge at the other end at a different point in time. However, there are many theoretical and practical challenges that would need to be overcome in order to make wormholes a reality. One of the biggest challenges is the issue of stability. Wormholes would require the existence of exotic matter with negative energy density, which is not currently known to exist in the universe. Additionally, even if a stable wormhole were to be created, it is unclear how it could be navigated or controlled. Despite these challenges, the concept of wormholes remains an intriguing and thought-provoking concept in the field of theoretical physics. The idea of a shortcut through spacetime has captured the imagination of scientists and science fiction writers alike, and has led to important developments in the study of general relativity and quantum mechanics. In conclusion, wormholes are a fascinating concept in the field of theoretical physics. They are a hypothetical tunnel or shortcut through spacetime that could potentially allow for faster-than-light travel and travel through time. While wormholes remain largely theoretical, they have captured the imagination of scientists and science fiction writers alike, and have led to important developments in the study of the structure of the universe. Wormholes are a fascinating example of the power of theoretical physics to push the boundaries of our understanding of the universe.